Hello everyone, how are you? This is Yair again, and I'm going to stream myself solving Advent of Code again, question number 14. Um, and um, a friend told me, it's surprising I have not looked at each of the questions before each of the live streams, so actually it's kind of like a double, in a way, I think, more authentic demonstration of using Lamdu when facing a problem like Advent of Code without any planning. Yeah. Um, but don't worry, I am pretty relatively quick. Things like these many years ago, when I was in high school, I competed in the computer science or informatics Olympiad. And yeah, and I also worked, so I have some experience with solving algorithmic questions under time pressure. Yesterday, I was very hasty in my stream. And the main reason was I was hungry, and I also needed to go to the restroom, but I didn't want to take a pause in the live stream, so I just rushed through it. So today, I have some cookies here. Actually, I'm a bit hungry. And I went to the restroom in advance. Okay, so I'm going to start at 8 p.m. sharp. And I will put my phone on quiet. So I can show you yesterday, usually after all of the haste in the live stream, I make my solution nicer and share it in the functional programming and the future of coding Slack groups, sometime in the Lamdu subreddit. And yesterday's question actually, the sharing was mostly like in this one method here, Advent 13 check, but other than that, the logic between the two parts was different, so I made distinct functions for part 2 and part 1 instead of just having a condition within them. Both had this comparison of strings, describing kind of nested lists of numbers, and some rules, basically some custom comparison rules. And yeah, and then when parsing nested lists, we needed to not break at commas if we are inside parentheses. So I had this fold where I count how much parentheses I'm in, and I only break if the depth equals 0. And then the first one was pretty simple. It was mostly, I guess, testing the comparison, and the second one wasn't much more difficult. It added the sort, and it needed a bit more careful look at the instructions that we're adding additional lines to the input. The first one had pairs, and here we ignore the empty lines between the pairs in this case. Yeah, I'm looking forward to see what today's question is going to be, and hopefully I will be more relaxed and explain better my line of thought and what I'm doing today. As I'm doing this, I'm also collecting, kind of doing personal user testing, because I'm also a developer of Lamdu, which is a passion project currently worked on by myself and my friend Eyal. But we are looking for contributors, and we also opened the GitHub sponsors open collective thing, and if someone is really a big philanthropist, then contribute financial contributions ahead as well. Maybe we will be able to actually hire a developer to work at this. Currently, it's kind of when we get the time to keep developing it. And this month, my work in Lamdu pretty much sums up to playtesting for this, which I'm doing every day. And here in Sound Radix, let me rotate the camera. We are working on a new release that hopefully will be out soon. I hope people are waiting for it. You guys dealing with recording and mixing, you know who you are. So the time has come, and I'm going to look at the question. So advent of code, right? And question number 14. So we're more than half done. And I'm gonna skip, find the input. So I don't know if this one is the input or if this one is the input. Yeah. So yeah, this one is an explanation, and the first one has to be the input, I suppose. And then we'll read about it and see what's going on here. So yeah, let's start with pasting the input, and it looks like it's made out of lines, so let's do that. And looks like every line is, let's turn on the evaluation annotations. So yeah, we can use type annotation, by the way, which we can see what type everything is. A lot of it is redundant, and this text argument has been automatically renamed text. Let me explain. I'll undo. When I typed map and chose it from the completion, it already filled in a lambda. And it's not really, like, it's in italic, meaning that the name is not committed. If the type gets inferred to something else, it will change. But if I give it a name like line, then it's not in italic. This is a name I've chosen, and it's not going to change it, except maybe to add a suffix if there are two line variables which we need to differentiate because they are both in the same scope. So let's use the value annotation, and let's split the line on these nice arrows, right? Which we see, and yeah, this is the first part. And these look like coordinates, but my face is in the way, sorry. Yeah, so we have this 4984 thing over there. Yeah, so I will do a let item. I pressed my face is over where the keys are. Sorry for that. Undo. Yeah. So I pressed Alt L, sorry. I can press the keys, but I don't remember to tell what they are. To make a let item. And, I'll just split text over the comma, collect it into an array. We have two parts. And we're probably going to have like a record with X and Y, but let's go back to the problem description and read what these are. X and Y coordinates, right? So let's do that. We have X, which is, we're gonna parse the first item, and then we're going to parse the second item. And at is our array array read operator in a certain index. So now we have these, and currently it's a list with the map over there. If I do like this toArray thing, it becomes a parsed array, and it shows as a table, which is nice, as you see. And for it, it looks like it parsed correctly. Now, whether we want to do that depends. Whether if we're iterating over the array more than once, then we may want to collect it into an array. But if we're only going through once, not that the parsing is very involved, then the split kind of returns an iterator that and the map that figures it out as it goes over it. So you don't necessarily want to collect everything into arrays. Yeah. So what do we actually need to do with this? So we're behind the waterfall with the stress following a distress signal, and we're analyzing falling material. We're looking at a two-dimensional slice of the cave. Air with structures made of rock. Okay, so these describe walls, if I get it correctly, which are drawn here. And and we are concerned with simulating sand pouring into the structure around these walls. Wow. So for this, we'll need to heavily use mutation. Okay, so either we create mutable arrays and simulate the sand falling from above, or that could be slow. I don't know what part 2 is going to be. If there's a really big gap between when something starts to fall and when it reaches the bottom. So we may want to hold structures describing the columns. And if we do that, we may as well not use mutable structures. We can have a structure of columns, and we can make like linked lists describing what's going on from top to bottom, and we share those. Um, yeah, and we may actually want to use the zipper idea of holding the current column where things are falling from, and like all the columns to its left and to its right by the order of their vicinity to us. I know what is going to be the simplest. So I guess let's not start with a zipper. Yeah. It's not. Things fall to the top. From the top. Well, yeah, if you hold, yeah, so let's first try to convert the map to columns. So let's not do the two array and call this whole thing. Let's make this Advent 14 example input, and let's call this Advent 14 parse, and let's take input as a as a parameter. And now let's do Advent 14 parse of Advent 14 example input, and we got it parsed. Now we will want to, it doesn't matter if things overlap. Suppose let's turn each line into just consecutive pairs. So let's do this. Each line we will we will zip it with with its tail, and when we're left with more items on the left side, we'll ignore this, and and we'll have pairs. We can call this start would be LHS, or we can just export it as LHS and RHS. I guess those are bad names. So let's do start is the LHS and end is the RHS, and then we'll concatenate all of them. Concatenate, and so now we have all these lines, and I guess some are horizontal, some are vertical. Let's turn it into an array, and then we will let's let's look what the horizontal ones are and the vertical ones are, because we can maybe be more efficient. Well, I don't know, maybe we don't need to be efficient. So now let's start with something inefficient. I'll turn off the annotation so this is less noisy. So let's have something called columns. And you know what, let's also have like minimum x equals from array r dot map. Let's take here this minimum of start dot x and end dot x and dot x, yes, and yeah, we'll take the minimum of this, and sorry, it's this minimum. Now this one reduces over a list and returns a maybe. Actually, we know we're supposed to have something, you know, but if not, let's go with 500, which is where the sand is coming from. And we also want max x. So you know what, let's, instead of this silly thing, let's make another one of x's. X's, just for the minimum and the maximum, will be r dot map. Sorry, yeah, we can fix it here, r from array, and we'll make a list of start dot x and end dot x, and we'll concatenate that. Yeah. And actually, we can go over these in one pass and calculate both the minimum and maximum. Sorry, I didn't mean to close that. I meant to delete this one. Yeah, so I'll just fold over these x's and we can put them here, I guess. Let's do the simpler fold that always goes over all the items, like fold R in Haskell, for example. And here we do min x start at 500 and max x start at 500. And now, you know, we do min x dot min with item, and we do max x dot max with item, and we now have min x and max x. And yeah, if we took this into let's call it accumulate min max, yeah, min x max x, right? Cool. So now we'll iterate over the various x's. Max x plus 1, sorry, plus 1, and we'll build the columns. So I'll be going over all the lines I hope it's not too inefficient. And we'll have a list of where blocks start and stop. So let's go over and by the way, let's make also this function, let's call it advent 14. Take the input and we parse the input that we are given, okay? So let's go over this array, from array, and I guess I'll map over it and either produce stuff or you know what, let's do the fancy fold thing. Yeah, so this fold with the continuation allows me to produce a list or an iterator while I haven't finished folding, and that happens in the continuation. So, you know, map, I suppose, is implemented this way. So it produces items, but then the rest will be produced later when the map iterator is consumed via this continuation. So yeah, let's use the same idea here. So what do we want to do? If start dot x equals let's call this column, and yeah, the abbreviation is col, but it's not used because of this appearing here. We need to refine the rule of when abbreviations are not applied. So if start x is column n, end dot x is column equals column, then we have a vertical line here, and we'll just use start as the minimum of their y's, I guess. I don't know if we should use the accumulate min max for that. Then it won't be called start and stop. But it's actually a nice function. You know what? Let's make a new function, call it min max. Min max. Yeah, and it has a left-hand side. We'll make it an operator on the right-hand side. And yeah, my keys are actually showing on top of the code, which is not ideal. We'll just return record with minimum being LHS dot minimum. Or actually, maybe we want to make just a single comparison. So let's do if LHS smaller or equal than RHS, then we have minimum equals LHS and maximum equals RHS. Otherwise, it's the opposite. So this is the RHS, this is the LHS. Well, let's use this min max. Let's delete this accumulate min. Oh, no, actually accumulate min max. has nothing to do with this min max. Sorry. This accumulate min max is accumulating with with the existing items, but we can still use it here. So let's do min max of start dot y and end dot y. Sorry, I need a. Actually, I'm not sure. I should need a parentheses here to type it. I'm going to look over all of these videos to collect issues to fix in Lamdu, which tries to feel like text editing. It's close to it, but it's not quite, and I don't know if it ever could feel just like text editing. Oh, but the benefits are worth it. You never have syntax errors. You never have type errors in the way you have them in other languages, like Haskell or like C++. And you do have types, not like Python. So start is this minimum one, and end is this maximum one. Right. All is good. So, and it gave it a suffix to differentiate from some other usage of min and max. I'm not seeing it, but it has to be here somewhere. So we are accumulating parts of walls. Okay, so if start.x is smaller or equal in column and end.x is greater or equal column, then I'm assuming it's a horizontal one, and I'll just do start is is start dot y, which should also be the end. It's going to be the same y because it's all horizontal lines in these examples. All the walls were horizontal, like it said, right? Sure hope so, I guess. Oh, and yeah, we're not done. We should continue, right? Same here. We should continue with the continuation. Otherwise, we just continue with the continuation. Yeah, this pipe stands for explicit lazy evaluation, and cont is already of this type, basically a lambda that gets nothing. And yeah, we don't pass anything during accumulation. The accumulator is actually redundant, and when we're done, we're just done. Great. Now we have these, and let's actually sort over them. Such that we are sorting by the y value, so we have the first y first. So LHS dot y dot start, I guess it's not y, smaller than RHS dot start, because we want to merge like overlapping pieces of wall to make it canonical. Or you know what? Maybe not, maybe in part 2. Let's assume there are no overlapping ones, all right? So let's open a new REPL and put it on top and call Advent 14 with Advent 14 example input. And let's go to this hole here and this column, like the first one, shouldn't be empty. Like something was at this X. Right? So X494. Something was there. Yeah, the last one had something with 494. Oh. No, yeah, this condition is wrong. Like the start and the end are not ordered. So so what I want to say is that if I was going to check the minimum and maximum of their y's, let me show you this though. I was here in the condition. I was going to change. I pressed Command L, no Alt L to add the let item, and it changed the sugar to not be in elif form anymore because it has this let item here. So that's a convenient thing that doesn't happen when editing in other languages. Like it doesn't just go out of the sugared form for you. So I'm going to use this min max we made for the, and actually I don't need to get rid of the condition completely. Yeah, it's just going to do, okay, min max of, yeah, the start dot x and then I'm going to use the parentheses to make sure it applies on the end, even though it does. Now this is not going to be start.x, this is going to be min2. And this I'm going to use max 2. So okay, now yeah, now there is something here. So the first one has in is the Y4 in the 494. No, it's not. It should be 9. So what's going on here? So let's go over. The first one is 494. And this one is false. And the second condition no. This is not correct. No. Oh, sorry. I should have used X here. Okay. Okay, now we're good. Now we're good. So, yeah, and this column thing, let's, we can make it into an array. Right? Array. So, oops, sorry, what did I do to array? I wanted to get all of columns Shift left, shift left. Yeah, I think so it's easier without the annotation. The code is more containable. Yeah, all of this to array on it. And it should be an array now. So yeah, and I have to look later what these data dots are, because I don't remember. Sorry. But I guess we don't want to show things too deep. You know what it is? It's something to do with our UI framework. Oh, no, I don't know. I'll have to look into it later. It looks like that's what it's showing for. Instead of showing that there's a record inside and it has start and the end, and then actually the ones that have more than one item show up as a table. If I'm reading this correctly. I don't know. Yeah, so this one is in 6 and 9, but then this one had one stood from 4 to 6 and another one 9 to 9. Yeah. Oh, there is some overlap, 4 to 6 and 6 to 6. Yeah. So I guess a way to avoid the overlap would be all the way when we zipped before, to make the lists actually not start all the way at the RHS or LHS. But I don't know if it matters really. I guess it depends what we do with this. So we have some redundancy in our columns. So what do I want to do with those? So I want to simulate sand dropping and accumulating on the stuff, and to tell when it flows out. How many units of sand come to rest before the abyss? And here they're saying it took 24 units of sand. Okay. So let's see. We'll have some sort of step. So I'm going to loop and have some sort of, iteration counter, 0, and state, which is the state, which is this array. I'm going to put it here. Not this array, sorry. Columns. I'm going to paste it here. And I call it state. Maybe I shouldn't call it state, I should call it columns. Okay, now we want to compute where the next piece of sand falls. Right? So I'm going to do another inner loop, if you will, starting with x being 500 and y being 0. So let's see, what are the rules about the sand? Yeah, okay. So we want to find out where this falls down. So we're doing another loop with this dot loop. And actually, instead of 500, let's do 500 minus my minimum x. So now it's in units of our columns, starting at 0, right? Yes. Hi, Neil. Good to see you here. So today it's a more involved question, but I guess the advent of code gets more difficult as time goes by. I had ones that I finished, in less than 10 minutes, but this one will take more time. So to simulate where it falls down, we will look at the column at this x, and yeah, by the way, if I want the evaluation to happen, then I have to keep the type the same as when I was, I'm just not I just haven't enabled evaluation, I guess. Yeah. So you can see, reach the hole, go to this hole, okay. So this column, okay, where it starts, there is a block in place 9, right. And now I want the simulation to also work if it doesn't fall from the top. So I'm going to ignore all of the pieces that are above us. So let's iterate over these parts in the column. So from array of columns, we will filter end is bigger. I don't know if bigger or equal to our current position. Is that ever going to happen? Yeah. So end should be bigger than y. Right now it's all of them. And they're already sorted by the start. So now I'll do first where, no, actually they all end. So if there's anyone, if the list is not empty, then we will fall on this block. So let's just pattern match over this list. If it's empty, that means we are falling out. We are falling out. So the result would be the iteration. Yeah, and actually that's the whole thing. So yeah, this. Okay, so if I turn off the evaluation, things are cleaner and I can go and You know what? Let's extract all this to initial, or no. Let's just put everything here. Go here and tell it that the result should be a number. Okay, and turn on evaluations. Yeah, so there is something starting at 9. That's where we are going to fall to. So our y is going to be here, but then it says that the sand is trying to fall either horizontally to the left or to the right from there. So we have to check those as well. Yeah. So we have 2 candidate positions to check. Let's say candidates. There are 2 of them. Actually, you know what? Anytime something falls to the leftmost or rightmost column, no, to the leftmost column, it is guaranteed to end. So let's make these 2 candidates. Basically, we have x here being x minus 1 and y being y plus 1. With the streaming setup, it looks like it never happened to me before, but Lamdu, it appears not to be catching some keystrokes occasionally. So I have to type not too fast, which is also good to make the stream more followable, but probably a bug as well that we should fix. Okay, so these are the candidates I have to check. And what should I do with those? I should find the first one of them, which is free. There's nothing blocking it. So basically, if it's out of bounds, I'll define it as free. So if x1 is smaller than 0, or x1 is bigger or equal to the number of columns, so length of the array of columns, then that would be fine. That would be free. Actually, I don't need to do an if for this. I will do an additional or. So either this or something complicated. So So we're going to take, let's make a let item of, well, no, actually, let's just take it. So we have the columns at x1, and we're not interested in, oh my, I gotta, let's turn off the evaluation, see if it's more snappy without it, because with screen capture and live streaming, it's not keeping up. So I'm going to filter, no, not filter. I'm going to only consider those that don't start after me, and they are sorted. Oh, I need to, this is an array, the columns, okay? So I'm going to do from array, because I guess that's what sort gives. And I'm only going to take them while start for smaller or equal to y1, which is our candidate y. And then all of them should end before y1. So end 5. Oof. A lot of start and end, so they get suffixes, huh? But when it's automatically managed, I don't feel bad about names like start 5. I don't know. Yeah. So we're looking for the first of these candidates, which if we turn on evaluation now, then the result is just the first one. So it didn't even compute the second one. You see, this denotes laziness, and it didn't get to compute what x plus 1 was here. All right. So if one of them is free, then let's put them in here, not call them candidates, because we were already filtered over candidates. It's not the candidates. Then I will pattern match over it. What do you think? Yeah, if none, then the sand has fallen here. But otherwise, we continue with in the loop with this new position, right? So yeah, with this new position. Okay, so we have the path of the. It's interesting that the evaluation actually chosen it to be this way, because x5 and y1, if we look at the map, x of 5, why is the y1? Oh, no, that's the wrong y. You see, we needed to go with we needed to first let it fall all the way down, right? So what did we do? We iterated, no, this is, sorry, it's not this y, it's actually start 3. It's where there is a block, but to the right or to the left, that's where it should fall. Right, so the candidate positions to fall to with the start with 9 and either 5 or 7. It's not the same indices they have here, but whatever. And actually, yeah, this green line denotes it's going here. So in this case, we need to add this piece of sand here. So what I'm going to do is we need to take another step, cont 1, and you know, it's the next iteration, so it's iteration plus 1, and the columns now we need to change them. So yeah, we need something to change an array in place. So let's make a function to call like modify array. I don't think we have it like before. It's not in our standard library. It's also not going to be terribly efficient with these. That's why we don't have it with these functional data structures, because I didn't use the. So yeah, we'll have an index, and yeah, we'll have a modify function, and we'll make it into an operator. And we'll do like array from array, and I will zip it with indices, so like from 0 to infinity, and you know, we're going to assume, no, we're going to stop when the left one stops, empty, and I'm going to do if RHS equals index, then I'm going to modify the LHS, otherwise it's going to be unmodified, and I'll return it as a new array, to array. Which I will use here to modify array of columns in X, yeah. And now I just want to add a block here. So I'll do yeah, actually I already have columns at X here. If anyone is going to watch the soccer World Championship, have a good time. I will keep finishing this task, at least part 1. So binary, if you're going, yeah. So I'll just modify it here so I can make it into a extracted. Or I guess I can. It's the same as columns at XFS at X0. So okay, from R1, and I'm going to map over it, all right, and make a new array. You know, and what am I going to do? If start 6 equals, or yeah, start 6 equals this previous start we've been using. Is it start 3? Yeah, it's this one. Then I'm just going to make it, start 6 minus 1. It's accumulating a piece of sand here. Well, I need to make a record, and it's going to have the same end. So end is end 6, all right? And this is x2, which is start 6 minus 1, or just start 6. And man, I think this should be it. So let's see. No. Ooh, what error have we faced? So this is another case of something bad going on, but we translate into JavaScript, which we had some problem in the JavaScript side. It didn't translate into a nice Lamdu error, but last time it happened, which I will collect after this whole playtesting project. We may be accessing arrays out of bounds somewhere. I don't know. I guess I can try a simpler example. Like, what if it was empty? Maybe not empty, but we have like one arrow, maybe the first arrow, like this. Then it should be done immediately, right? But what if this one went further? And it's in like 500. Okay, so this actually should be 0, but it's not. So let's follow along. Okay, so we start. Let's make things easier to manage. So I will take this into a function called this use the min x and max x. Should also use otherwise. So it uses a lot of stuff from scope, so maybe it's not good to extract it into a function. So forget about it. So let's just turn on the annotations and see where the loop got us. Okay. So it continued to x3, y4. Actually, it may have been easier if x was in the original stuff. And it got to a second place. So there's an so 2, 0, got to 3, 4. And then what happened in 3, 4? Three might be out of bounds is the deal here. Oh yeah. Oh yeah. So we need to add like a bounds check. Right? Yeah, there might not be columns at this x. So instead of num, if something, then num. Otherwise, we're out of bounds and we're done in this iteration. And what is the condition? It's this x0 is larger than 0 and x0 is smaller than the length of the columns. Isn't that so? So now let's see. This ends at 0, but what if it was longer? Yeah. So now let's see what's going on with the Advent 14 example input. 24. And what did they say? "24 units," right? So let's try with my input then, right? Let's see what it is. Get my puzzle input, copy, and let's put it here. Let's call it Advent 14 my input. Put it here, close it, and it's a bigger map. It may take more time, but 625. And we're compiling to JavaScript now, so it's not very quick, and I also didn't do a very efficient algorithm. So submit, and that's the right answer. All right. Okay, there's a floor at the bottom, and we're standing at it. Okay. So part 2, we can add a floor, but I don't really want to make it infinite. I just want to reuse what I did in part 1. Yeah, let's go back to the example input, right? And add a parameter called part2. Now this won't run because it's not the right arguments. Let's turn off the annotations though. Right, so we want the record input, Advent 14 example input, part 2, whatever, false. Yeah. So we want the maximum y of this array. Yeah. Okay, actually, let's not really output this array, but do like if if part 2, then something. Otherwise, we're doing this array. Oh, and now it knows that part 2 needs to specifically be a Boolean and not any type, because I made a condition on it. So if it's part 2, going to check the maximum y, right? So I'm just going to fold over ry but r1 but from array. No, I'm going to do the simple fold actually. Always consumes all item from array r1 initial value is 0, and I will do like the max of the accumulator and start dot y and end dot y. Oops. Yeah, this maximum is no, not the list maximum, the operator, sorry. And the end dot y. So we have the maximum y, and we want to add. Did advent 14 parse, by the way, did it sort them? No. Okay, just checking. Back. So what did I do here? Undo. Yeah. Oh, why do we have a hole here? Oh, this was the array. Anyhow, this should be array 0, and this should also be array 0, sorry. Okay, no holes except for this one. Okay. So I'm just going to do toArray, and I'll add something to the previous array, which is they said it's at the maximum plus 2, so it would be num plus 2 and yeah, I don't know, in the end let's make it so it's a platform holding this thing here, right? So it's going to be 500 minus, let's call this thing, let's call it y. And I meant this was supposed to be y. And if this was at like at 1, it should have been the platform minus 1. Okay, so this would be 500 minus y, and let's do 500 plus y, and now I should have the platform underneath. But if I start blocked, it also ends now. Doesn't matter if it's part 1 or 2, because it won't happen in part 1. So this loop we're doing, oh yeah, we are finding so basically we were looking at stuff that ends after us. We were assuming that we were before them because everything we checked was for that. But that will no longer be the case. And the starts were sorted. So we just need to add a test here. Yeah, let's do it outside all of this stuff. So, yeah, when the code doesn't quite fit the screen, maybe that's a sign I should, so I can of course reduce the font size, which is what I'll do now. Yeah. So we're going to do a condition. If if the start is smaller or equal, then what did we filter? We filtered for the ones that end after us, and the first start, yeah. So if the start is smaller or equal than us, which is y3, then we're not y3, what was it? Oh, this filter y1, sorry, it was n3. Then we're also done. Otherwise it's this number, num command v. Yeah, let's close it and see. So part 2 should still work the same, 24. What if we have part 1, 93? Is this correct? 93. It is correct. Oh my god. Advent 14, my input. It's going to take longer now. Yeah, we saw I didn't do the most efficient algorithm in just how I store my data. We could have used mutable arrays, but it's always nice to do functional code and avoid them if possible. And well, part 1 was quicker. Part 2, if it doesn't finish in a reasonable amount of time, then we'll have to modify it to do the zipper approach, where instead of rebuilding an array all the time, we work with linked lists of the current column, like with linked lists of the columns to each side. And the thing with the zipper, we can like traverse left and add ourselves to the right list and pop one from the left list. And yeah, and we don't have to go over reconstruct all of the list of columns every time, just the columns that we are considering. Also, I don't know, how big are the numbers here? Yeah, 121, wow, it's a big map. It could be quite a lot of steps, and we're basically simulating every single one of them. I don't know if there's a more efficient algorithm. Haven't paused to think about it. So I guess I will cut because it's not going to finish soon, I guess. I will cut the stream without submitting the answer for the second step, which I will resume at a later time at my own leisure. So for anyone who has watched, thanks, and I will share the final solution, of course. So, cheerio.